Welcome to the Cortex training blog. This tutorial will introduce you to a great graphical interface to Caesar 2 that offers an extremely efficient method of creating accurate specification-based Caesar 2 models. The graphical interface I'm about to demonstrate is available as a free download. It is essentially a demo version of CADWorx that will read and write native Caesar 2 files. Now, CADWorx sits over the top of AutoCAD, so to use this interface you'll need access to AutoCAD. I want to illustrate the ease of use of the CADWorx front end by creating a model that we've already used in the Input Basics tutorials that we posted elsewhere in this learning log. There are about 9 of those Input Basic tutorials. I want to introduce you to a really nice, accurate, efficient and convenient way of doing exactly what we did in those 9 tutorials. Okay, this is the screen you'll see after you've downloaded the demo version and started it up. The demo will not let you save drawing files, DWG files, but it will let you read and write native Caesar 2 files, which is exactly what we want to do today. So this tutorial will only skim the surface of all the features that are available, and we fully expect that anyone who uses the free download should contact us to get help getting started. So let's get moving. First up, let me open up the configuration screen and make sure the system's ready for us to start building our model. Okay, so first up we've got a number of different drawing modes. I like to use the 3D Enhanced because it shows bolts and so on. I want to use a metric environment. As you can see, there are a number of other environments, metric inch, English inch. I also want to make sure that we've got the right Caesar 2 version that we're going to be interfacing with, which looks okay. This is spec driven, so we need to set up a specification and a size. So first up, let's browse to these specification files. These come shipped with the demo, so there's no need to create new ones out of the box. You can use these, and they'll be suitable for most pipe stress applications, especially for the American codes. So we'll choose the metric spec, and you'll see here that we come up with a number of different specifications. These ones are related to flange rating, so we have a 150 pound spec, 300 pound spec, and so on. So I'll check the 300 pound spec, which is what we're going to be using. Then I next need to just set up a default pipeline size for when we're starting to draw pipe. So I'll select 250, which is 10 inch, as per the model that we're going to be building, and I'll arbitrarily select a 300 branch size. We can change those at any time in the model. Okay, so now let me start building our piping system. Well, first up, let me just show you that we can change these pipe sizes anytime we like, and we can change the spec as well. Okay, now let's get on to building our piping model. We click on the pipe in the menu on the left hand side, and we simply drag our cursor out, and in normal AutoCAD command we just type in 1900 millimeters. That will create a 1900 millimeter pipe segment in the Z direction. We just move our cursor around through 90 degrees and type in the length of the next leg, another 90 degrees and another 1900 millimeters, and we've got our first section of pipe built. What I want to do now is insert a T into this horizontal section. I grab the plus sign, which will signal to the system that I want to insert a component. By default it inserts a T. So I'll click that, and you see it comes up with a T. Next thing it's asking me for is a dimension to where that T should lie. I'm going to use an AutoCAD command to select the midpoint of that pipeline. So I just right click and check midpoint, and click midpoint on that pipeline, click. Now it's asking me for a direction. I just point upwards, and a distance, which is going to be 7 meters, 7,000 millimeters. Okay, so that's got my vertical section. I'll just pan up using normal AutoCAD commands, turn the cursor through 90 degrees, and type in 2 meters or 2,000 millimeters for the horizontal section at the top. Okay, in the model we had a couple of valves down near the base, so let me show you 2 ways of putting that in. There are a number of ways of doing it. I'll show you 2. Okay, so again I can click on this plus sign, then click L for list, right click L for list, and it'll pop up with a series of components I can insert. One of the sets of components is a valve, so I'll click on a gate valve, and once I've selected the gate valve, the system then asks me for a dimension at which I want to insert this valve. If I click J, I can toggle the dimension from the front of the valve to the middle of the valve to the end of the valve. So as you can see here, the valve is moving around as I type in J. And if I want to go back and sort of dimension to the first part of the valve, I just hit J a 4th time, and there we are. Now I just type in the dimension I want to have to the front of the flange, click, and there's the valve. An alternative way of doing the same thing is to select from the menu on the side. So let's grab a gate valve. To tell it where to insert it, I just right click, select nearest, locate it on the pipe, and again it's asking me for a dimension. This time it's from the opposite end of the pipe that I want, so I'll type P to switch the dimensions location. And now you can see I'm dimensioning from the other end of the pipe. I want to justify it to the closest end, and I'll type in 400 millimeters, and there's my valve. The final thing I need to do to get this model accurate is to change this vertical leg. It was drawn in 250 mil pipe. I really want it to be 300 mil. So let's go up to the change size command. This is quite an intelligent command. I'll go back, once I've selected the component, the command, I just need to select the components that I want to change size of. Click and drag, normal AutoCAD type commands. I also want to grab that T. And once I've selected those components, it asks me what size I want to change it to. I'm going to select 300. And the smart thing is that the program is asking me now, it realizes that I need to put in some reducing components to make this all work. So it's selected one side of the T and says I'm going to need to insert a reducer. And it's asking me whether I want a concentric or an eccentric one. So let me choose the concentric, and likewise on the other side I'll choose a concentric one. So now it's asking me to select which component I want to keep stationary, and I'm just going to make that the T. Once I've selected that, just hit enter, and bingo, the whole piping system there has changed in size, and it's inserted the reducers as necessary. So that's basically it. I've created that model really quickly, and I want to output it to Caesar 2. To do that, we use the system out command, and that writes a native Caesar 2 file to a folder on our network. So very simple, just click system out. It will ask me to select the components. Oh, sorry, to select a file name first. So let me go into an appropriate folder. I'll change the drawing, the name of the file to pipe_1. Now it'll ask me to select components. I could also do this by selecting a line number or elements from a database. They're reasonably advanced. Well, line number is not advanced, but database is a little. But I'm just going to select the components that I want. Keep it simple. Select those components, and see, it's now asking me whether I want to provide start locations. I can actually force the node numbering to start at different locations if I want to, but it'll do some. It'll provide defaults for me, and I'm happy enough with those. So now it's writing the file, and soon it will pop up and tell me that it's been completed. Here we are. So that's okay. Our job here is done. So let me close CADWorks and open up Caesar 2 to look at this file. Okay, navigate to the same folder, open the piping file, and look at the input. Okay, so notice all the data's come through. We've got materials, elastic modulus, all that sort of stuff has come through, and that's all because it's a spec-based thing. I can add different components here if I want to. I could have added these in CADWorks, but yeah, I can also add them in Caesar 2. So let me just finish off the model by putting a couple of restraints, a couple of anchors on these endpoints. I'll put a displacement on the last element. This is just to create exactly the same file that we did in our 9 tutorials previously. Putting some displacements on here. And once I've done that, I can click a button and perform an analysis. As simple as that. So we're just running through the error checking. Everything's fine, no errors. With a little bit of number crunching time before Caesar 2 comes up with an output screen. And once that happens, we can go in and analyze the results. So here we are. That's as simple as it is. So for those of you who are interested in downloading a free version of this CADWorks software, please get in touch with us at support@cortexsoftware.com.au, or you can phone us on that number there, and we'd be more than happy to introduce you to the product.